Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you.
Welcome back, team. And I think we are discussing about how do we build and deploy the application, right? Especially on the Spring Boot application, right? Good. I think the scope is for today is to understand how do we run a front-end application, correct? Well, so I think let me go ahead and deploy a front-end application, okay? So only the Java-based build and deployment will be a little tricky since it has the Maven and the JFrog integration, right? And the Sonar integration, lot of things. And the front end build and deployment will be straightforward. I'll quickly show you how that will be, right? And usually from the interview perspective, right, everyone will be interested on how do you or how good you are at doing the build and deployment of a application, guys, right? No one will care about the front end application. Whether do you know the build and deployment process of the React application? No one really care about that because the process is very straightforward, right? So everyone will look at your application layer only, the backend, right? Well, so in my Bitbucket repository, I can see there is a React.js application, right? Think of like I got a code from my developer. The code is committed to the specific repository, to the specific branch. Now, as a DevOps engineer, I need to take this code and build it and deploy and run it as an application, right? So let me take this code into my build server. I'll copy this link. So I have the EC2 instance currently running. I just have logged into my EC2 instance. This instance now I'll make it as a build server, right? So first what I do is I will be installing the Git server so that I can start doing the clone process. So now let me run the command called git clone. It is just cloning the source code. So this is the React.js application, and either it is a React.js or it is a AngularJS. The build and the deployment process pretty much the same. There will be no difference. There will be slight changes in terms of the coding, how the developer will be doing, but from the build and deployment perspective, the commands, the process, everything will be the same. Okay, and here I can see my application related source code, correct? So as usual, here also you can see the src folder, right? Under the src, let me show you the folder structure, guys. Like how the Java application has a folder structure, in the same way the React application also has a folder structure. You can see the src. Inside the src, you can see all of the different JavaScript related files are located. We don't need to worry about all of these, right? How the things are being developed. Let the developer will take care of. I'm just showing you that where actually the source code is located. Okay. Now let me come back to the parent folder. Okay. So I'll just go to devopsrealtime.com. Some steps are documented in the website. Let me go to the documentation. Yeah. So here you can see certain terminologies that you should be familiar with the React.js application build and the deployment process. Like how do we use the Maven as a build tool to build the Java source code? In the same way, here we are using the software called Node or Node.js. Both are same, guys. Okay, so either you call it as Node or you call it as Node.js. Both are pretty much same. Okay, so Node is the software which I'm using here as a build tool in order to build your React.js application and run it. So when you install that means what? Now I need to install the Node software in my system where I'm doing the build process. When you install the Node software, which is the build tool in this case, right? The Node will give you the NVM commands. The Node will give you the NPM commands as well. Okay. The NVM is like a Node version manager, right? Which will take care of certain, package installations and software installations, so on, so on. And npm is the node package manager, which again takes care of installing certain third-party libraries, all these things, pretty much like what Maven is doing. Maven will look into the pom.xml, understand the dependencies, then download the dependencies from the external repositories, correct? The same kind of the role is happening here as well. So here it has a npm in order to download and install the required third-party libraries, and NVM is again managing the node software itself, right? Upgrading the node software or whatever, right? That's how few terminologies like this. Anyway, for us really not so important to understand the roles and responsibility of each and every component that you see here, right? So I just wanted to give you some glimpse, that's it. Okay, all what we should understand, right? How do you install the node software, and what are the commands that I need to follow here in order to build and deploy the application? That's it, right? So I will simply follow this article in order to download and install the node software, and I'll show you the commands to run to do the build process of your React.js application. So here you can see some steps. First, I need to download the node application binary. So let me follow the commands as it is. So I'm just trying to download the software it into the OPT location. And this is the command that I'm using to download the node software. Of course, you can go to the Google, go to the Node.js website, the way how I'll go to the Maven website to download. We can go to the Node website and see from where the software can be downloaded. So since I have the commands handy, and let me go ahead with these commands as it is. So I can see that the Node software is downloaded. The next command is I need to extract the archive. Let me run the command to extract the zip archive. Now you can see that the node software is available in the specific folder. Now I need to update the path environment variable in order to run the node related commands as usual, right? So let me run this command in order to set the path variable, so that in which location the node software is extracted, that will be set into the path, so that the commands can run from anywhere that you like it, right? Let me run this command. Now let me verify my commands are working. npm is the command to see the version. Let me see npm hyphen hyphen. Let me see npm version. Yeah, it's working. Maybe I need to update my documentation. The hyphen should not be here, right? So this is just telling that what and all different versions are available, right? And that's fine. So now let me see one more command called node version. So this is specifically to look at the node software version. You see the node hyphen version. I can see that the 16.18 is the version that I'm using here. Like, how you have a Java versions in order to build a Java source code, right? The Java 8, Java 11, Java 17, right? So the Java version should be compatible to the source code, right? How the developer is suggesting. Same way here as well, whatever the React.js application code that is developed by the developer should be compatible for the specific Node software, because Node is the one who is now responsible to build the code, right? So it has to be compatible. So in our case, the code that I have taken here is compatible for the Node 16 version, and hence the reason I'm using the same. If you are using the different version, probably my code may not work as expected, because the developer is writing the code very specific to the version compatibility, right? Good. Now let me come down. So now I need to download my React.js application source code, which I have done already. Now this is the important step. Probably install the node modules, and npm install is a command that you need to run. This command will take care of downloading certain node related modules, right? So if I go back to this source code, so this is the source code that I have got it right from the Bitbucket repository. And here you can see a folder called node underscore module. If you go inside that folder, if you do ls-l, you can see there are a lot of modules that are available. Like, how you are using the import method, sorry, how you are using the import in the Python in order to import the modules which are available in the external repositories. You import them and use them in the current code, right? Similarly, here in the node, there are certain modules that it would be needed. All those modules will be get downloaded from its repositories, and to get those modules downloaded, need to run the command called npm install. If at all the developer is giving the node modules already in this folder, let's say in this case, I got the node modules folder which has already there the required modules. So now I need not to run the npm install command to generate this modules. Got me? Most of the times the developers will keep these modules ready in the repository so that you don't need to run the npm install every time to create a modules, because that may generate the modules of the different versions sometimes, and that may not be compatible. The build may get failed. So in this case, since I have the modules already with me, I need not to run the npm install command. If the modules are not available as part of the repository, then you need to run the npm install. But again, you need to check with your developer, right? So how to install the modules? Is there any specific flags? Which versions has to be downloaded? There should be specific documentation that the developer has to provide, right? How to run these commands in order to prepare the stuff. We are just simply following the developer instructions here. How will you be building the source? Nothing much, right? So I'm not running this command for now since I have the modules already available, right, in my repository. Now the next command is npm run build. This is the command that you need to run in order to build the source code. Okay, so let me run this. The command has to be executed from the present working directory where the actual source code is available. So by default, this command will be looking at the pwd, and it will get the details from the package.json file. Then it will start the build process, guys. Like how the Maven was looking at the pom.xml file in order to build. Similarly, the npm is looking at the package.json file. This file has certain details how the build has to go, and it will go for the build process. So here now I can see that after several lines of output, you see that the build is successful. When the build is successful, you will be getting the build output in the file called build. You see here, build is the folder, right? In that folder, the output will be stored. Not like a Java. In the Java, you will get a single artifact file, right? Either war file or jar file like that. But when it comes to the React, the build outcome, the build artifact is the bunch of files. If you go inside the build folder, you see all these are the files that are generated as part of the build process, right? So now you need to have all of these files in order to deploy and run the application. It's not a single file, guys, like how the Java is giving you a single war file or a jar file, right, which is the Maven artifact. Here you will not get a single file, you will get multiple files like this. All of these files are generated into a build folder once the build is successful. Now we need to take all of these files and start doing the deployment process. Let me see how I can deploy all of these files to run the application now. And you see the command that I'm using, the next here. The developer has given you a deployment folder. In this folder already there is a folder called dist, and the files that are generated as part of the build process, all of the files has to be get copied it into this dist folder. Let me do that for you now. Let me clear the screen. You see there is a deployment folder. If you go to the deployment folder, here you can see there are certain files already. The developer has given all of these for you. It has some package.json, index.json, and some of the modules, so on, right? And in this folder, if you look into the dist folder, the dist folder is currently empty, right? All what you need to do is the files that are created in the build folder as part of the React.js build process, all of these files has to be now get copied it into the dist folder, right? Once you copy all of these files, then your deployment folder will be ready for running the application. Let me do that. I wanted to copy all the files which are there in the build folder it into the dist folder. Now if I look into my dist folder, I can see all of these files available. Now I would say that the deployment folder is now fully ready to run the application. To run the React application, you would need all of these files, guys. You need a build files in the dist folder, and you need a index.json, you need a package.json, all of this stuff. The developer has given all these required set of files for you. You don't need to do anything, but you just need to ensure that build it, keep that content into the dist folder. That's it. It should be ready. For any reason, if it is not working, again, you need to get, check with the developer only, and the developer has to assist you on this, how it has to be. The process may vary. If the process gets vary, the developer will give you the instructions how exactly the build has to be done, right? Now I have my deployment folder ready. Now in order to run the application, all what you need to do is from this deployment folder, right, you need to run the command called npm start. So npm start is the command to run the application, guys, right? Let's say in the Tomcat, how I was running the command called, like catalina.sh run, sorry, start. Similarly, here I need to run the command called npm start. Let me run this. So the npm start command by default is looking into the present working directory, looking into the index.js file, and the file is already coded by the developer how it has to be, and it will just pick up the files from the dist folder, and the application is started. React application, or we can simply call it as a node application. right, is by default listening on port number 3000. So currently I would say that the npm start command is starting the application, but currently it is starting the application in the foreground process. You see that I'm not getting the shell prompt, right? That means it is currently running the application in the foreground. Of course, that's not ideal case. You should run it in a background only. But for now, I'm just showing the command how to run the application, right? So do you think the build and the deployment both will be happen on the same server, guys, in general? No, right? Here I'm showing that how to do the build, and I'm showing you how to run the application as well. But in general, you will not build and run application in the same server. The build server will be different. The deployment will be in a different, right? Once the build is successful, once the deployment folder is ready, all the content of this deployment folder should be shipping to the destination or to the target wherever you wanted to run the application, right? That's how it works. Anyway, for now, let's see if this application works on the port number 3000. So all what I can do is I'll go to my server. As of now, I'm running this application on the EC2 instances directly, not on the container, right? Of course, the best way to learn about it is, right, any new tool that you are learning, first you learn it how it can be run on the direct EC2 instances. Then you think about how to, uh, convert it into the container model, right? So for now, let me allow the port number 3000 to see how the application is looking. Let me copy the IP address here and go to the browser. And I wanted to access the application on 3000. There you go. So this is how you are getting the UI page, right? Of course, you are not getting so much graphical thing. That's fine. As long as my website is working, I'm good. How the developer has written a code, accordingly your website will come, right? But at least good that I have got something, and I got sign in, sign up, and the company logo, all of this stuff, right? And if I click on sign up, you will get some sign up form where you need to fill up and register an account. Sign in is logging into the existing account, right? And yeah, this is the logo. So far so cool, right? So you may be thinking now, how come the logo is coming in, right? Just to give you some context here, right? For now, let me do Control C because this is running in the foreground. I'm just terminating the process. Okay. So if we look into the source code, right? If I look into the source code somewhere in the files, give me a second. So let me see the public. Yeah. So somewhere in the file, right? Somewhere in the index.html file, you see this https :// and this is look like a S3 bucket endpoint, correct guys? I have the S3 bucket, right? And in the S3 bucket, logo.png is actually the object that it has to. The reason why I'm showing all of this, though we are not a developer, right? Why I'm showing this? We should understand that the developer will be mentioning your S3 bucket endpoints where exactly the logo file is there. That logo file related endpoint is mentioned in somewhere in their code. So when this code is built and deployed, it will pick up the logo file from the S3 bucket, and that file is being appeared on your website here. I just wanted to show that how the developers will make use of the media files that are currently in the S3 bucket, no other reason. but you don't need to worry about the whole syntaxes here because it's not your responsibility to develop the code, right? Good. So that's it about the React application. So simple, right? Build and deployment. There will be no JFrog. There will be no code quality. All of these, of course, the code quality is possible to integrate with the Sonar, but yeah, not that much critical at this time, right? This is just a front end. The more importance will be given for the app layer only, right? And the JFrog will not be needed here because the build artifact of the React application is not dependent by any other applications, right? Usually in the Java application, the reason why I'm pushing the artifact to the JFrog is possibly that artifact might be a dependency for some other projects. So I need to keep it in the JFrog that will be downloaded by other projects. But when it comes to the front end, like a React application, this React application artifact, the build artifact is not dependent by some other projects, right? That is not the nature of this application. Hence the reason you don't need to store this artifact in somewhere. Even the artifact itself is not a single file, right? It has a bunch of multiple files. It's not a easy way to keep them it into a separate repositories like how I'm keeping the war file or jar file it into the JFrog, right? So hence the reason we don't need to worry about keeping this artifacts in somewhere else, right? Just take this artifact and you run the application. That's fine. Let me clear the screen. Of course, as of now, I'm showing you how to run it in your standalone machine like EC2 instances. We'll definitely see how these can be run in the Docker containers. I mean to say the Kubernetes later point of the time, right? So the plan is we can't jump onto the Kubernetes deployment directly. First, we should understand the behavior of the application, how it runs, if the manual steps on the standalone EC2. Once you are good with this, then we'll see the improvements how we can run it in the Kubernetes, because that is the final goal, right? The goal is not to run on EC2 directly, right? The goal is to run on a Kubernetes. We'll see that transformation in later. And of course, by this time you all know that just matter of creating a Docker file and compose the Docker file accordingly how you wanted to run the application on the target Kubernetes cluster, right? Good. I just wanted to open one other slide, guys. It should be under files. It should be recent. Let me call out Edwiki Training. I just wanted to go back to the three-tier architecture that I was referring through here, right? The communication is coming to the front end. The front end is actually directing the traffic to the back end. The backend is connecting to the database, right? We already familiarized that how the backend is connecting to the database, correct? We already given the database endpoints in the application.property file in your source code, right? In the Java source code. That way the Java know that, hey, this is the backend, sorry, this is the database endpoint and the credentials. So the Java code will connect to the database. Good. Similarly, right, the Java application endpoint, in the sense how a Java application can be accessible, that endpoint will be coded in the front-end configuration. That's it. The way how you have a application.properties file for the Java application, right? Even the front-end application will have its own configuration file where it has to be. So how your application, how your backend will be accessible, and that information will be kept in the front-end application by your developers. That way, when you build and deploy the front end, it know it has to connect to which backend, and it will be connecting accordingly. Right? At this time, we need not worry about in which configuration file we are keeping the backend information. All of these. right? That is something the developers will be taking care of, right? So based on the endpoints that it has to use, right? So I have shown you the application dot properties because that's little important at application layer, but in the front end we don't need to worry too much. The developers know exactly where it has to be mentioned, right? But in general, in the SRC, there will be a file called app.jsx. So in this file, there should be, right? In this file, there should be some routing functionality somewhere you can see, right? So if someone is calling this sign up activity from the front end, it has to go where. If someone is clicking on the login, it has to go where, right? So on, so on, so on, so on, right? So which we don't need to too much worry about from the code perspective. That's the reason I'm not stretching much on this, how exactly the developer is keeping the backend information in the front end code. Getting me? Because there is more of code related stuff, how they are managing it. Hope you are good on this. Now, so I see a good question on the chart window. So what is the endpoint of a backend, guys? So the endpoint of the database, probably you know, which is the MySQL endpoint that you get it from the AWS RDS console, right? Good. But what is the endpoint of a backend in the sense of how the backend will be accessible? It's all based on the backend is running in which compute, right? Is it running on EC2? Is it running on a Docker container? Is it running on the Kubernetes pod, correct? If it is running on the EC2 instance, then the EC2 IP address will become the backend. Just look from the perspective, right? If it is running on the EC2, EC2 IP will become the backend. If it is running on the Kubernetes as a pod, then what will be the endpoint for you guys, right? The endpoint will be your ingress routing, right? I mean to say the cluster IP. The cluster IP service, right? The cluster IP service is the access methodology to access your backend, right? So the cluster IP service will become the endpoint here. We'll see more details once I jump onto the Kubernetes, but yeah, that's how it works. The endpoint of the backend will vary based on how you are running the application, where you are running the application, right? That's how it works. And that has to be given to your front end, and that will be get connected. So as I see a question in the chat window, the front end will be taken care by the developer means what? The developer is again to write a code, nothing else. It's a DevOps engineer responsibility to ensure that you take the code, you build it, and you run it. Nowadays, most of the developers are actually taking care of by themselves itself to even running the application as well. But initially to provision the setup or give the required details to the developers, how they can build and deploy it into the Kubernetes, right? All of this stuff has to be done by the developer, sorry, DevOps engineer itself, right? Now, so definitely I'll talk about how the front end is connecting to the back end to the database, all these things in a while, maybe once I get into the Kubernetes again, okay? So being said that, now we got some insight about the front end, back end, database, all this stuff. Now the time for me to switch the gear and talk about something else. So today, most of the time I'm spending for the theoretical discussion only, and it gonna be a little crazy to understand these concepts, guys. And I just wanted to give you some context that whatever I'm covering today, you will get full understanding after 3-4 lectures only, not by today itself, okay? Because I'm going to kick off the CICD project today, and it takes at least 3 days of time to complete this CICD project with the implementation. So once until this is completely done, you will not get much clarity, guys. But if any questions, feel free to bring it up. So now I'm introducing you the Jenkins CI pipeline. Okay. So the thing is, again, let me go back to my previous statement. As a DevOps engineer, your responsibility is to take the code from the developer and you follow all the steps, whatever is needed to deploy that application it into the production and run it as expected, correct? So when I say all the steps, right, it could be a build steps, it could be a deployment steps, it could be creating the images, or it could be pushing to JFrog or pushing to the code quality, whatnot. So in general, in one single statement, I would say that once you get a source code from the developer in the Bitbucket repository, it's your responsibility to take the code and follow all the required steps, right, until that is being deployed it into the production. That means first you deploy it into the dev, then to the QA, then to the perf, then you promote that it into the production, right? All these steps has to be done by a DevOps engineer. So far, I have shown you the Java application, how we can do the build and the deployment process, right? How can we do that? So probably you take the source code, right, that the developer has committed to the Bitbucket repository, and then you take that source code and you do the Maven build. Once the Maven build is completed, then you push your build to the Sonar for the code quality analysis. Then once the quality gate is passing in the Sonar cube, then you publish the artifact to the JFrog so that that artifacts may be useful for some other projects whoever is depending on, right? Once you have the Java artifact is there, let's say the jar file is available in the artifactory, how are you going to deploy that, correct? So that is where now you need to create a custom container images. So what is the goal, guys? Once the Maven build is successful, where are we planning to deploy this application? In previously, I have shown you that once the Maven build is successful, I have deployed that into the EC2 instances directly, right? And I have shown you how to run it in the Tomcat. But is that the goal for us? No, right? Our goal is to run that application in the Kubernetes as a pod, correct? Following me? And we need to recollect a lot of concepts that we covered previously in order to understand this whole process that I'm bringing in today, right? So once the Maven build is successful, once the artifacts are prepared, then my next step is I'm going to create a container image out of it. What is that I'm going to do in this container image process, guys? In general, high level. So whatever the artifact that is got created like a jar file, that jar file I'm going to add it into my container image, correct? Remember, usually you get a container images from the Docker Hub, right? Initially, but whatever the image that you get it from Docker Hub registry, that is a very generic one, correct? That image will not carry any specific application related code base, correct? Getting me? So let's say you go and get a image from Docker Hub, that is just a software and the dependencies and the minimal OS. You will not get any source code, right? The source code is something very specific to your project. So that source code is actually built and created as an artifact for you, right? That artifact, now you copy it into the Docker image and you create a image out of it. And we'll see definitely how to write a Docker file for that and all of this, right? Once the Docker image is created, that image you publish to your Docker registries. It could be a Docker Hub, could be a JFrog, could be a Amazon ECR, whatnot, correct? Whichever the registry that you are using to store your Docker images, you push your images to the Docker Hub registry. Now with that, you have the image ready with you. Agree with me? Now, once you have the image with you in your registry, how are you going to run this image in your Kubernetes containers, guys? Since all the required basics to understand the today concept are already done. So we should be able to know recollect the concepts now. So once the image is ready in a Docker Hub registry, how are you going to run that image in your Kubernetes containers? Sorry, in your Kubernetes to run as a pod, right? You include that image, right? You include that image in the Helm chart, right? And of course, you need to write a manifest file, and in the manifest file, you need to specify the image details, which image that it has to pull, that I agree. But we already discussed it, right? We are not going to deploy the manifest as a manifest format, right? All of the manifests that I'm going to use to do the deployment will be combined and will be created as a Helm chart format, right? So that's the reason I'm saying that once the image is ready, then you include that image in the manifest files and you create a Helm chart out of it. Once you have the Helm chart with you, then that is the Helm chart that I would need in order to deploy it into the Kubernetes cluster. Agree with me? So whatever the Helm chart that is got created, right? That Helm chart now I'm going to publish to my JFrog Artifactory and I'll keep it there, correct? Why? So in this entire process, right? Whenever the developer is giving the source code in the Bitbucket repository, right? I just need a Helm chart in my JFrog Artifactory in order to do the deployment, correct? That is my final or the target state that I'm looking for. So the Helm chart is the deployment ready artifact for me. Once you get a source code from the developer to the Bitbucket repository, all the steps that you are following here in order to prepare a Helm chart, keep the Helm chart in the JFrog Artifactory, all the steps are called as the build stages. I'll call it as a build stages. When I say build is not just a Maven build. The build terminology now has a broader picture. When I say build, it includes the Maven build, Sonar analysis, pushing to JFrog, creating a Docker images, creating the Helm chart, keeping that it into a JFrog Artifactory. The whole process that I'm covering here is called as a build process. Are we good with this? That means when I say a build, that means you do whatever you wanted to and create a final deployment ready artifact, which is the Helm chart in this case. I think I have done all of these steps already, right? Manually, right? I have executed the git clone command to get the source code from the Bitbucket repository. I installed the Maven. I ran the Maven command to do the build process. I ran the Maven sonar command to do the sonar analysis, then pushing to the Artifactory. And of course, we know how to create a Docker image by writing the Docker files. We know how to create a Helm charts by writing the manifest files. And we know how to push the Helm chart into the JFrog as well, correct? Pretty much, I have done all of these steps manually, step by step. Agree with me? Tomorrow, when the developer says that, hey, I have the source code ready in the Bitbucket repository, I don't want a DevOps engineer is putting the efforts in terms of running all of these steps one by one manually, because this is the repetitive process, correct? Let's say today the developer will give you the source code. Will you be spending the time in running all of these steps, all of these stages one by one manually? If so, you would take, let's say you will be spending some 2 hours of time to run all of these commands one by one, one by one. Let's say after 3 hours, the developer says that, hey, I just made one more change in the source code. Can you take the latest code and do the build? Will you be again cloning the repository and performing all these build stages manually? You getting me? That means every time when there is a source code changes in the Bitbucket repository, what is your outcome, guys? When there is a change in the source code, what is that you are looking for here? I just need a latest Helm chart based on the latest Docker image, based on the latest artifact that is in the artifactory, based on the latest source code, correct? I'm just coming in the reverse way. That means whenever there is a source code changes, I'm expecting the latest Helm chart to be available. And for that, I need to run all of these steps one more time. In general, in a company, right, the developer is keep on doing the code changes. In a day, let's say, in a day, the developer is updating the code at least 10 times. And all the 10, each and every time there is a change, all of these whole steps has to be executed. So I don't want the DevOps engineers putting the effort in running them all these steps every time when there is a source code changes, which is the time consuming, which is the error prone, because manual steps always cause to some errors, and the delivery speed is not improving much, correct? When I say delivery speed, the companies are looking like this. Once the code is ready, how much time that you are taking as a DevOps engineer to build and deploy it into the Kubernetes. That is the major focus here. The expectation is once the code is changed in the Bitbucket repository, I want that code to be deployed it into my target, at least the dev environment, within a matter of seconds or minutes. That is my goal. Will that be possible if you're running all these commands manually one by one? Not really, right? So for that, now I need a automation solution in place, and the Jenkins is the automation for this. Jenkins is the automation tool, right, which can take care of running all these build related stages one by one in a proper sequential fashion as per your instructions. All what you need to do is you download the Jenkins software, you install the Jenkins software, and you tell to Jenkins software that, hey, this is what you need to do. That means, hey Jenkins, whenever there is a latest code that came to the Bitbucket repository, can you please take care of a DevOps engineer role pretty much? You as a DevOps engineer, what and all commands that you are running manually, in which sequence that you are running the commands, all these instructions now will be handed over to the Jenkins. The Jenkins will do your job on behalf of you. Now the Jenkins will clone the Bitbucket repository, the Jenkins will run the Maven command, the Jenkins will push to a Sonar, the Jenkins will ensure that the artifact is published into the artifactory. The Jenkins will ensure that the Docker images are created, ensure that the Helm charts are created and publishing to the artifactory. All these will now be done by the Jenkins software for you. When I say that Jenkins is doing all of these, is not mean that the Jenkins is doing the build, no. Is not mean that the Jenkins is doing the Docker build, no. The Jenkins is just to go and execute the required commands and informing to the specific tools that, hey, you now please take care of. Got me what I'm trying to, right? At the end of the day, the build, the source code build will happen by Maven only. The Docker build will happen by the Docker only. But the Jenkins is supervising to run the required commands in a proper sequential fashion automatically. So that way it is trying to speed up the delivery. When I say speed up the delivery, in the sense the moment the code is came to Bitbucket repository, immediately you should be able to see your latest Helm chart available in the artifactory by executing all of these steps one by one by the Jenkins itself for you. You don't need to run them. So all the concepts that we have done so far, like I have shown you the Maven build, the pushing to Sonar or whatnot, everything, right? All those are the manual steps that I have shown you, right? You will not be doing all these manual steps in a real time. All these manual steps now will be automated by informing to the Jenkins. The Jenkins will do it for you. So if then, what is your role? What is the DevOps engineer role? The DevOps engineer role is now to create a Jenkins automation such a way that the Jenkins can do all of these required build and the deployment related steps to be executed automatically. So there are multiple stages, right, in order to take the code and deploy it into the target environment. And as a stage, let's say getting the source code from Bitbucket is one stage. Stage in the sense like a step. Maven build is one stage, Sonar is one stage, JFrog is one stage, right? All these stages are properly connected in a proper sequential fashion here, right? Which is called as a pipeline. Pipeline is the terminology that we use here, which says that, right, the required number of stages that needs to be executed in order to prepare the deployment specific artifact ready of your source code is called as a pipeline. The Jenkins pipeline in the sense, so this entire pipeline, what I'm preparing here will be now executed by the Jenkins. So I'm calling it as a Jenkins pipeline. Now, can I use this statement? Whenever there is a source code that is committed to the Bitbucket repository by a developer, now the Jenkins pipeline will take care of running all the required build related stages to prepare the deployment specific artifact, which is the Helm chart in this case. The way how Jenkins works, right? I can even tell to Jenkins that, hey, you please go and look at the Bitbucket. Whenever you see there is a source code changes, you please follow running this entire pipeline process. That means I need not to go and inform to Jenkins manually when there is a source code changes. The Jenkins can detect automatically that, hey, there is a source code change. That way, the developer, the moment when the source code is committed to the Bitbucket, immediately the pipeline will start and it will follow the whole build process. Hence the reason this is called as a continuous integration pipeline. Why I'm calling it as a continuous integration? The Jenkins is now taking care of integrating the multiple different stages together to run automatically when there is a source code changes, right? I'm not informing to the Jenkins every time, no. How the Jenkins will do all of these, we'll definitely see in the implementation. I'm just trying to give you some background of this whole process, what I'm trying to target for. So the Jenkins CI pipeline is mean that the Jenkins continuous integration pipeline, which will be the automation pipeline taking care of integrating the multiple tools together to run in a sequential fashion to ensure that the build is successful or the build is happening when the source code is committed to the Bitbucket. In this pipeline, if you see guys, did I do the deployment? I mean to say, in this whole process, whatever you see in the screen at this time, your application is running in the Kubernetes? No, right? In this process, I just have ensured that the required Helm chart is being created and kept into the JFrog artifactory. That's it. I did not proceed for the deployment process here. So this is just a CI pipeline. If you are asking the Jenkins to do the deployment also, like, hey Jenkins, whatever the Helm chart that is created here, can you take that Helm chart and deploy it into the Kubernetes? If that is happening, then that is called as a CD pipeline, a continuous delivery pipeline. We'll talk about the CD pipeline later, how that happens. First, let me talk about the CI, how it works. In general, the people will say that the Jenkins CICD pipeline, that means the CI will take care of preparing the build artifact. CD is the automation pipeline that takes care of deploying that it into the target Kubernetes cluster or wherever you want it to run. Are we good with this? DevOps is all about the process. We should give a priority in understanding the process, not on the specific tool set. That means forget about Maven or Sonar or the JFrog. It could be a Maven or it could be any other build tool. It could be Sonar or it could be any other code quality tool, right? It could be JFrog or it could be any other artifact management tool, doesn't matter. So what is that we need to focus on is whenever the source code is committed to the Bitbucket, right? How I'm able to write a Jenkins pipeline automation script to ensure that it is processing all the required stages needed as per the developer's expectation and make it ready. That's it. You see, I'm just giving the generic explanation here. Why? Tomorrow the developer may ask you, hey, I don't want to use the Maven. It could be a Gradle. The developer may says that I don't want the Docker Hub. It should be a ECR repository. Sometimes the developer says that I don't want the Sonar Cube. Please remove that stage at all. Correct? That means what? The steps or the stages may vary based on the requirement, based on the programming language, based on the project nature. Need not to be the same always, right? Getting me, guys? So that's reason, in general, whatever the CI stages that are expected on that specific project behavior, you ensure that all of them are putting together in a pipeline fashion and you inform to Jenkins to behave or to execute it on behalf of you. That will take care of. That is called as a pipeline here. But in general, if it is a Java application, definitely Maven, Sonar, JFrog, Docker, Helm, these are pretty much standard stages that will be there for most of the projects, but need not to be the same. It could be plus or minus as well. Could be that. Well, I can see a question and as well as the answer. Now let me see this stuff, guys. So the goal is whenever there is a source code that is came to the Bitbucket repository and I just wanted to run my complete build related stages to keep my build artifact or the deployment ready artifact right. And this slide is very specific to the Java application, but it could be any other. Just the stages will vary, the build tools will be vary, but yeah. So if you know how to do the Jenkins CI/CD pipeline for the Java application, pretty much you are comfortable in any programming language, as I said, right? Because only the Java has significant complexity will be there. If you are using any other programming language, it's very straightforward, right? Like the React application is very simple. Just take the Node application, just two simple commands, right? Not much. And if you go for the Python, you don't even have the build tool. Just use the source code directly and just run it, right? That's the reason we are focusing on the Java here, which has a significant complexity in terms of doing the build and the deployment process. Now, so here I got the source code to the Bitbucket repository, right? And you see this is how the source code come in, correct? The developer will be keeping the source code in the src folder and you will be getting the pom.xml file, correct? Of course, if it is a React application, you will get something called package.json. So far, so good. So you will get a source code to the Bitbucket repository. That is where the DevOps engineer role will be started. In general, right? Once you get a source code in the Bitbucket repository, whatever is needed to take the code and run it in a Kubernetes cluster, everything is your responsibility, simply put, right? Let me show you this, guys. I have the EKS cluster with me, and I hope you are able to see my screen, and the cluster is in the bottom, the terminology. So this is my EKS cluster where I wanted to it's fine. Let me run through again, guys. Okay. So my goal is I have the EKS cluster with me, and I really wanted to inform to my API server that, hey, API server, can you please deploy this Helm charts, correct? Or the manifest files in a way. When you inform to API server that, hey, please do deploy this application, the API server will now be taking care of deploying that it into a Kubernetes to run as a pod based on your deployment configuration. Are we good with that? Right? Even if you talk about the Helm chart, internally the Helm is talking to the kubectl and then talking to the API server, and the actual manifest files will be get deployed. And we have seen that behavior, right? Good. So I'm just talking about my target. My target is I just need to inform to my API server to do the deployment that will take care of deploying your application to run as a pod. So whatever the source code that came to the Bitbucket, that has to be run in your pod level. That is my goal. What you do with that, guys, for that? So in general, there are two high level steps that you need to follow, correct? One is the build process, one is the deployment process. Are we good with this? The build process will take care of creating the deployment ready artifact, most likely the Helm chart in this case. The deployment process will take care of deploying that Helm chart it into the Kubernetes, start from the dev environment towards the production. I think previously what I did right for the build and deployment process, you go to the build server. For now, you just consider that this is the EC2 server, okay? So you take one EC2 instance, right, as a build server, and in that build server, you need to keep your build specific dependency packages has to be installed. Agree with me? You need to install the Git software on the build server, the JDK 11 or the Maven software, the Docker, Helm. You go back to my previous lectures, guys. I did all of these manually, right? So you take one build server. In the build server, you prepare all the required packages. You install all the required packages that needs to be available to do the build related commands to be executed. Then you usually run the commands manually, correct? What you do in general? Consider that this is a EC2 server. You need to do the build process. You need to run the git clone command to clone the Bitbucket repository. You run the mvn command in order to build it and publish the artifact to the JFrog. Maybe a node command if this is a React application. Then you need to run the docker build command in order to create a Docker images. Then you need to run the docker push command in order to push your Docker image to the container registries. Then you create a the manifest files, and you create a Helm chart out of it by using the Helm package. Then you run the Helm push command in order to push your Helm chart to the respective registry where you wanted to keep your Helm charts. Are we good with this? I think this is the manual method that I have followed so far in terms of preparing your Helm charts and keeping it into the registries. Finally, once the build is completed, your Helm charts are available in the Artifactory. Now you follow the deployment process, correct? For the deployment process, most likely you take the Kubernetes client, correct? You take the Kubernetes client where the kubectl is installed. So in the Kubernetes client, you install the required packages that needs to be. Probably you need a Git, Helm, and the kubectl, so on, so on. A question for you at this time. When we are creating the Helm chart will be created in a generic way, right? In the sense, the Helm chart will have the image details or maybe a deployment specific configuration, but not the values. Agree with me? Like the replica count, right? The port numbers, maybe some other values. In general, whichever the values that you feel that not same across the environment, those values you are not going to keep it in the Helm chart itself. So as much as possible, you prepare the Helm chart as a generic way so that the Helm chart will have only the configuration but not the values. And you supply the values later at the time of the deployment by externally supplying the values.yaml file, correct? How I'm going to do this now? Of course, I have shown you that previously in a manual method or as a concept, technical perspective. Now we'll see how that is going to happen now. I'm going to use one more Bitbucket repository. One Bitbucket repository, that is where I have got the source code. Another Bitbucket repository, this is where I'm going to have the branches. The dev branch will have the deployment specific values related to the dev environment. QA branch will have the QA environment specific deployment values file, so on, so on. How many environments that you have to do the deployment, you create that many number of branches, and in each branch you keep your values file. I think previously I have shown you, hey, helm install hyphen upgrade -f values.yaml, right? So that values file should be kept into the specific branch in the separate repository like this. So I think coming back to the build process one more time, I missed out one step. The git clone command will be cloning the Bitbucket repository, right? When you clone the Bitbucket repository, you will get a source code, and then you do the Maven build. Then you need to do the Docker build, right? To do the Docker build, you need a Docker file, correct? You need a Docker file. In the Docker file, you need to write a instructions or the Docker layers, how you are expecting the custom container image has to be created, which includes your Maven artifact, correct in this case? So the Docker file that is needed to build the Docker images is also kept into the same Bitbucket repository where your source code is came in. You see this slide? src pom.xml, that is the code that you get it from developer. There is a Docker file as well which you have written it, which has the details how the image has to be created. After that, to create a Helm chart, again you need a Helm chart templates, right? And you see the charts folder in the repository. Inside the chart folder, you need to keep all of your Helm chart related templates, like the folder structure. So when the git clone is done, it actually cloning the source code as well as the Docker file as well as the charts. Everything is came in. Then you just run all of these commands and create a Helm chart accordingly. Are we good with that? That means I'm telling that the source code and the required Docker file and the charts, everything is kept into a single Bitbucket repository that you clone it and you follow all of these steps to prepare a Helm chart for you. Probably previously I have shown you how to build it using Docker file, how to create a Helm chart using Helm charts, right? Now I'm putting everything it into a process oriented, showing that where the files has to be kept in, how will you be getting those files, all of this. I'm only integrating the process here, guys, to the concept that we did it already previously in a individual fashion. Anyway, coming to now to the deployment process, right? So what and all values that you wanted to supply to the deployment, you keep that values in the specific branches like this. Then in the Kubernetes client, you run the command called git clone. The git clone will be cloning this second Bitbucket repository, which will bring the values.yaml files. Then you do the Helm pull command, which will be pulling or downloading the Helm chart from the JFrog Artifactory. Can I use this statement at this time? By now, in your deployment server, in the sense your Kubernetes client, where you wanted to run the application, right? Sorry, where you wanted to run the kubectl apply commands or Helm commands. So can I say that now you have the Helm chart that you wanted to deploy, which is downloaded from JFrog, plus you have the values.yaml file, which is downloaded from the Bitbucket. Agree with me? If you wanted to deploy the Helm chart it into the dev environment, you get the values file from the dev branch. If you wanted to deploy it into the QA, you get the values file from the QA. That's how in which environment you wanted to deploy, you get that values file from the specific branches, and then you run the Helm command. The template will be the same, but the values are being changed. Here, the single repository is having multiple branches, right? Dev branch, QA branch, production branch, so on, so on. This concept is called as a multi-branch pipeline. Multi-branch pipeline in the sense, one repository is maintaining multiple branches to take care of the pipeline automation to do the deployment it into the multiple environments, right? So this concept is called as a multi-branch pipeline concept. We'll see the implementation, guys. We can't get into the implementation directly without understanding this whole architecture. What is that we are going to plan? Whenever you run the Helm install command, this command will now connect it to the API server using the kubectl backend definitely. Now the API server will start creating the pod for you. That is the whole manual steps that I have followed so far. A question for you at this time. The build server and the Kubernetes client where I'm running the git clone, helm install, helm pull, all this. Do you think these two servers are needed once the build and the deployment is completed? You don't need, right? The build server I used just to run the commands for the build process. The deployment, again, the Kubernetes client where I'm running the commands, right? It's just to run the commands and connect it to the API server. Once my application is running in the Kubernetes as a pod, I don't need any of these. So that means it's not a best idea to take one EC2 server and run the build commands there. Take one other EC2 server to run the deployment commands there. No. Why? Why should I be keeping these two servers always running? You getting me what I'm trying to? Why should I be running the EC2 server running the build commands, one other EC2 server for my deployment? Not required. I need to do little more improvise on the process. Let's see how we can do that. Now this is the actual game. So far I talked about is what I did it so far. Sorry, is what I did it before in our lectures as a manual steps. Now I'm introducing the Jenkins. And let's see how the Jenkins can handle this. Again, there are n number of different ways are available. How are you going to create a pipeline? How are you going to make the automation in place? There is no standard way that this is the only way that every company has to follow. No, every company has their own way. I mean to say, all the companies may using the Jenkins, but the way how they are using the Jenkins to make this happen will differ. It's up to them how they wanted to customize and make the things. Being said that, whatever the process that I am following here is the pretty much recommended most of the companies are following, but it may or it may not be, guys. I just wanted to give the context again. So that you don't need to think that everyone is following the same method. No, it's up to them. There are a number of ways are there how we can achieve this. Anyway, we'll see how I'm going to make use of the Jenkins now to do all of this stuff for me. I need to install the Jenkins software, right? Where do I need to install the Jenkins software? You install the Jenkins software inside a pod only. I don't want to go to EC2 instances anymore. When I'm in the EKS cluster or in the Kubernetes cluster, whatever we wanted to run it as a pod only. That's the goal. Following me? Of course, it is possible to install the Jenkins software on the EC2 server as well. If you want, you install the Jenkins software on the EC2 server. You tell to Jenkins that, hey, you please deploy my application into the Kubernetes cluster. Possible. But will that make sense? Right? You have the flexibility to run any applications in the Kubernetes as a pod, then why again you need to run your Jenkins application, Jenkins software on the EC2 instances? Getting me, guys? So the Jenkins software which I'm using here to make the whole automation is again running as a pod inside the same cluster only. You'll see how to run the Jenkins software in the EC2 in the pod. Just for understanding purpose, if your Jenkins is running on the pod, can I consider that this pod is now the build server? Just for understanding, can I consider that this Jenkins machine, the Jenkins pod is now acting as a build server for me to run all of the commands, correct? Of course, yes. If then in the Jenkins pod, I need to have all the required packages to be installed, correct? In order to run the build related commands. Whatever I did previously, I'm doing the same again, but in a different way, right? So you need to ensure that the Git, JDK, Maven, Docker software, Helm software, all these commands, sorry, all these base packages to be installed on the Jenkins pod where my Jenkins software is running, right? Then the Jenkins software can run the commands for you automatically. Whenever you say to Jenkins, hey Jenkins, can you do the build? The Jenkins software will now be running the git clone command, mvn command, docker command, docker push, helm package, helm push, correct? Yes, we are running the Jenkins software as a pod in the same Kubernetes cluster. Now, the Jenkins is taking care of running all these build related commands for you on behalf of you, and I would say. Even when you ask the Jenkins, hey, could you please do the deployment, right? The commands that needs to be executed, right, will be get executed on the Jenkins pod. The Jenkins will now run git clone to clone your multi-branch pipeline repository, helm pull, and helm install, all of this. Make sense, guys? What I'm trying to do? So if you are expecting the Jenkins is running the build related or the deployment related commands in the same Jenkins machine where it is running, then this is called as a Jenkins standalone. When I say Jenkins standalone, it means that it's a single Jenkins machine which is running the all the automation related commands, the scripts, stages in the same machine. In this case, you see it's a single pod where my Jenkins is running. It has all the dependencies and it is running all the commands for you. So overall, the build and the deployment will take care of. The problem is, let's say I have some 100 applications with me. When I say 100 applications, just for understanding purpose, can I say 100 Bitbucket repositories? Correct now? So as of today, I'm working with one application and one Bitbucket repository, right? But in general, if I say 100 applications, forget about what those applications and what will be happen. No, there are 100 applications. The developers are writing the code for them. So definitely there will be 100 Bitbucket repositories. Imagine guys, if all the Bitbucket repositories are being updated with the code changes by the multiple developers, if my Jenkins has to take the code from all of these Bitbucket repositories and has to follow the build and the deployment process, now you imagine how many builds and how many deployments that my Jenkins has to handle at the same time. Getting me? So that means now the Jenkins will become overburden. Always you think like the Jenkins is like a human, like a DevOps engineer. Okay, the Jenkins is like a DevOps engineer. Can you do the build and deployment of all the 100 applications at the same time? All right, so overburden. So here also the Jenkins will be get overburden to run a multiple builds and the multiple deployments at the same time, because it is now handling the commands execution in the same Jenkins machine itself. There is no parallelism here. What is parallelism, guys? Parallelism in the sense running the builds and the deployments parallelly, right? Uh, uh, like multiple builds at the same time. That capability is not there now because it's running as a single Jenkins. It's running the commands in the same machine, which is not a recommended way. Which is not recommended way. To make this improved further, right? What I'm trying to do is I'm going to create a Jenkins file in the Bitbucket repository, in which Bitbucket repository I have the source code is available. In that repository, I'm going to keep a Jenkins file. In this Jenkins file, I'm going to put all the instructions how the Jenkins can go with the stages execution process. In the sense, what commands that the Jenkins has to run, in which sequence the commands has to be run. All these instructions are now kept in the file called Jenkins file. You see now the git clone command, Maven deploy command, Docker build command, Docker push command, Helm packaging command, Helm push command. All of these commands are now kept in the Jenkins file as a scripting format. Similarly, all the commands that are needed to run for doing the deployment, those commands, those instructions you put in the Jenkins file, which is there in the specific branch. Let's say how you are expecting the deployment it into the dev, you put that instructions in the Jenkins file, you keep that file in the dev branch. Similarly, you create a one more Jenkins file and you keep the instructions how and what commands to be get executed, right, to deploy it into the QA like that. You see the Jenkins file which is in the dev branch. I'm keeping the commands like, hey, to do the deployment it into the dev, right, it has to run git clone, then the helm pull, then the helm install. I'm just putting some instructions here. I mean to say, somehow we need to tell to Jenkins, right, which commands that it has to run. So all that instructions, I'm putting it into the Jenkins file in a scripting format, in a pipeline format, and that file I'm keeping it in the corresponding Bitbucket repositories. Obviously, you cannot keep these instructions in the Jenkins file in a plain text format, right? It has its own syntax too. So you need to follow the groovy long ways. You need to follow the groovy long ways syntax in order to keep all these commands in a proper syntax related way in the Jenkins file, which is now called as a pipeline script. Like the script that you follow in keeping all these instructions in the Jenkins file is called as a pipeline script, because in the Jenkins file you are going to keep all these instructions in a stage by stage. First, which stage has to be done, then what is the next stage, what is the next stage. There is a specific syntax, we'll see later, but we just follow the syntax and we'll keep all these instructions in the Jenkins file that has everything to tell to Jenkins what needs to be done. As I see a question in the chat window, like a same Jenkins file, what does it mean by the same Jenkins file, right? If you have 100 Bitbucket repositories for 100 applications, every Bitbucket repository will have their own Jenkins file that has the pipeline script, how that particular source code has to go for the build process. And every environment, let's say I wanted to deploy it into the dev environment, the dev branch will have its own Jenkins file, QA branch will have its own Jenkins file. That way you explicitly define how we are expecting the deployment should be done on that specific environment. The source code Bitbucket repository will have the Jenkins file that has the details about the CI process. The multi-branch repository will have the Jenkins file which has the CD process. Are we good with that? For CI, there will be one Jenkins file. For CD, every environment will have its own Jenkins file. Dev has its own Jenkins file. QA will have its own Jenkins file. The production will have its own Jenkins file on the corresponding branches. That way you have the flexibility to deploy, right, as per the environment per se. That's how it works. As I said, the way how I'm implementing the build and the deployment process here may not be the standard way. It's up to you. You can easily manage the things in a different ways as well. There are n number of different ways how the people can manage this process. I'm just coming up with the better and the easy process to make the things happen. What and all the different alternatives are there to make the things can discuss later just in general. Well, now I was talking about the parallelism, right? In the sense, I don't want my Jenkins is running all the 100 applications to build and the deployment related steps in the same Jenkins machine itself. Getting me? That's overburden in terms of your Jenkins pod will be get crashed definitely because your Jenkins pod would need more processor, more memory because it is running the commands for almost 100 related 100 different applications, and at the same time if it has to handle, it's not possible. Hence the reason I'm telling to Jenkins that, hey Jenkins, you don't execute all of these commands in the same machine itself. You always act as a master. That means, hey Jenkins, you act as a master or you act as a manager. You delegate that execution process. You delegate the pipeline execution process to the slave Jenkins nodes. That means I'm going to create a one more pod in my Kubernetes cluster. This pod also running with the Jenkins software, but this Jenkins is called as a slave Jenkins. So here you can see the first one, right? The first Jenkins that I was talking about will now become the master Jenkins. The second pod that I just created is now called as a slave Jenkins. obviously, when you are creating the slave Jenkins pod, the pod in the sense what? There is an image, you just need to take the image and run it as a pod, correct? So how the slave Jenkins pod has to be created, you have the image already with you in a Docker Hub registries, correct? So from the Docker Hub registry, you pull the image which will be helping you to create a slave Jenkins, and then you deploy the slave Jenkins pod. The slave Jenkins pod will be ready. Now all the build related commands that needs to be executed needs to be executed on the slave Jenkins pod, not on the master Jenkins pod. That's the expectation here. If that is the case, the question for you at this time, the Git, JDK, Maven, Node.js, Docker, I said, right? All these are the different packages that must be available on the machine where the commands has to be executed. Now, do you think that all these packages should be there on the master Jenkins pod or on the slave Jenkins pod? You would need a lot of visualization to understand the concepts, guys, and of course that's possible since we have got the basics already covered. Now, since I'm expecting the actual pipeline execution will happen on the slave Jenkins pod, all the required base packages must be there in the slave Jenkins pod only, not on the master side. So when you are creating the slave Jenkins pod, that means the slave Jenkins pod will be created with the help of the image only, right? So you create a image and you keep the image in the Docker Hub registry. That image has all the required prerequisite softwares installed. That's how you need to write a Docker file and prepare an image for you. So if you are using that image, it brings all the required packages in the pod, and that helps us to run the required commands over there. Now, whenever you are expecting the build has to be done, let's say there is a code that is committed to the Bitbucket repository. Okay, now I wanted to do the build process, right? The master Jenkins, okay, the master Jenkins will go to the Bitbucket repository, will get the Jenkins file, because the Jenkins file has all the details, right? What and all different steps has to be executed, in which sequence the steps has to be executed. Everything is there in the Jenkins file as a scripting format, right? The master Jenkins will get the Jenkins file from the Bitbucket repository, then it will hand over that task. It will delegate that task to the slave machine. Hey, slave pod, you please take care of running this whole bunch of instructions that are there in the Jenkins file. So the master is there just to manage the stuff. Master is not going to execute the commands by itself. Master will just inform to the slave pod, right? Hey, slave Jenkins, you please execute the commands. Now all the commands that you mentioned in the Jenkins file will now be get executed in the slave Jenkins pod only. You see here the git clone, Maven deploy, Docker build, Helm package, Helm push, and keep the Helm charts in the JFrog. Everything is happening on the slave Jenkins. Tell me one thing, guys. Once the build is successful or the build is completed, once you have the Helm chart ready, available in the Helm in the Artifactory, do you need the slave pod to be up and running? You don't need, right? Same concept. Previously, I was saying that the build server is no more required once the build is successful, right? Same way. So here, the slave pod will be get terminated once the build is successful. I don't want the slave pod to be, because I have my Helm chart ready in my artifactory. I don't want my, the slave pod that will be get terminated. After some time, let's say there is a source code committed to the Bitbucket repository. Developer has made some other changes. Again, I need to run the build commands, right? The master Jenkins is again creating the Jenkins slave pod automatically and run the commands for there. Once the build is successful, the Helm is available in the artifactory, then again the slave pod will be get terminated. That means you are not going to create a slave pod manually. The master will take the decision when the slave pod has to be created automatically. Whenever there is a source code committed to the Bitbucket repository, master will identify that, okay, the time for doing the build, master will create a Jenkins slave, then it will delegate that that task to the slave pod. The slave pod will execute all the commands, then the slave pod will be get terminated. We'll see the implementation, how exactly the things will work out, like how the the slave pod will be get terminated automatically, right? How the slave pod will be created automatically, we'll see that. But if you look into the Jenkins file, guys, here you see one more step is added here. Git clone, Maven deploy, Docker build, Helm push, all these are the build related commands, right? Additional to that, you see there is one more build pod template. That means you need to tell how the slave pod has to be created automatically. All that related instructions should be kept in the Jenkins file itself as a pod template. That way, the master Jenkins will read the Jenkins file, will read the pod template configuration, then the master will understand how to create a slave pod. With the help of the pod template instructions, it creates the slave pod, then it will delegate that build operation. Once the build is successful, then the slave pod will be get destroyed. Are we good with this? After some time, if there is a source code changes, again the master Jenkins will read the Jenkins file, will read the pod template, will create a slave pod, it will delegate the task, all the commands will be executed, then the slave pod will be terminated. That means at any given point of the time, only a master Jenkins will be up and running. The slave pods will always come and go. The slave pod will be created when the requirement to run some instructions. Once that is done, the pod will be get deleted. How it has to create, how it has to terminate, you put all the instructions in the Jenkins file or wherever. Similarly, whenever you are expecting the deployment, let's say I wanted to deploy my application in the Kubernetes, right? You see here in the dev branch under the Jenkins file, you see the deploy pod template. That means you tell in the Jenkins file itself that how it can create a slave pod or slave Jenkins automatically for the deployment purpose. Whenever there's a requirement of the deployment, the master will be creating one other slave pod or one other slave Jenkins In that slave Jenkins, the deployment specific commands will be get executed. When it is running the deployment specific commands, it gets the branch, the environment specific values.yml. It get the Helm chart from the JFrog Artifactory. Then it will deploy. In the sense, the slave pod will be running the Helm install command that takes care of connecting to the API server. API server now will take care of doing the deployment. Finally, your pod will be get created. Once the deployment is done, once the pod is created, I don't need a slave pod, right? The slave Jenkins will be get deleted again. All the steps will be happening on the Jenkins slave only, including the git clone. That means whatever is there inside the Jenkins file, what and all different steps that you have mentioned, all of them will be get executed on the slave Jenkins only. Of course, I need to tell to master Jenkins that where is the Jenkins file. That's a different activity. You tell that where the Jenkins file, but inside the Jenkins file, whatever is mentioned, everything will be done on the slave Jenkins. Once the steps are executed, the slave Jenkins will be get terminated. Now, a final statement. Whenever you are preparing the Jenkins CI and the CD pipeline to have the automated build and the deployment process, so whenever there is a source code changes to the Bitbucket repository, the master Jenkins will be identifying the changes and will be creating the slave Jenkins pod and delegating that task to the slave Jenkins, and it will be executing all of the instructions, and then the slave Jenkins will be get terminated. If it is a CI process, the Helm chart will be publishing to the JFrog. If this is the CD process, we'll be getting the deployment in the target environment. That's how whole process works. Well, team, so I think that's the whole idea how the Jenkins concept works, but let me put the total summary one more time. It takes another 5 minutes to put a summary in place here. Let's see this now. So because I went through in the step-by-step approach, right, in understanding the process. Now let me put a final stage. So whenever you get a source code from the developer to the Bitbucket repository and expecting the DevOps engineer to do the build and the deployment process, you as a DevOps engineer, you need to contribute the required configuration files to the Bitbucket repository in the sense, right, you need to create a Jenkins master in the Kubernetes cluster as a pod. And this is interesting. You see the service account concept? Because the Jenkins master should be able to create a slave pod automatically. How a pod will be created? Obviously, it has to send the instructions to the API server only, right? Because the API server can create a pod for you. The Jenkins cannot create a slave pod directly, right? The Jenkins also should go and connect it to the API server. Hey, API server, can you please create a slave pod, correct? That's how the process works. If the Jenkins master is connecting to the API server in order to deploy the slave pod, the Jenkins master would need an access to the API server. That is where we need a service account here. Remember the concept that I talked about previously. The service account is the concept which you can attach to the pod, which will be giving the permission to access the API server, right? So you create a service account, you give the service account to the Jenkins master pod, then the Jenkins master will be getting the access. Now, what and all configuration files would be needed to do the build and deployment? You keep all of them in the repositories. That means you write a Docker file, how you're expecting the image to be created and keep it in the Bitbucket. You write a chart definition, how you're expecting the Helm charts has to be created, keep it in the repository there. You write a Jenkins file. In the Jenkins file, you start putting all the required steps that needs to be followed for the build process, including the pod template configuration, how a slave Jenkins pod can be created automatically. Then the Jenkins master will be taking care of getting your Jenkins file and delegating that task to the slave. As part of that, the Jenkins master will be connecting to the API server to create a slave because it has the service account already, and the slave pod will be created. All the build related commands will be get executed in the slave pod. Once the build steps are executed or completed, then the slave pod will be get terminated automatically. Here is the question for you at this time. Why the slave pod will be get terminated automatically, guys? The only reason is you will not be keeping any service up and running in the slave pod. In the slave Jenkins pod, you will not be keeping any services up and running continuously. Remember the concept. Usually, if there is no service running in the pod, the pod will go die, correct? That's a process. So you prepare a slave Jenkins in such a way that no process will be running on this. Whatever the commands that you have been asked for, those commands will be executed. Then it sees that nothing to run and the pod will be get terminated automatically. That's the whole idea, right? So once the build process is done, the slave Jenkins pod is got terminated. Now for the deployment purpose, you go with the multi-branch pipeline and maintain the deployment environment specific deployment values file and the corresponding Jenkins file in the branches, and specify the Jenkins CD pipeline scripts in the Jenkins file in your specific branches. When there is a deployment, the master will now be generating or creating a new slave pod and delegating this deployment task. Then all the deployment specific commands will be get executed on the slave Jenkins pod. You see again, the slave Jenkins pod is also attached with your service account. Why? The slave Jenkins pod in this case has to connect to the API server in order to do the deployment, correct? When it is executing the Helm commands in the slave pod to do the actual deployment, the Helm command should be connecting to the API server to do the deployment, right? So the slave pod should have the service account attached and give the access to the API server. Then the API server can go and do the deployment. Once the deployment is done, your slave Jenkins pod will be get terminated again. That's the thing. Any questions to me? So whatever I discussed today, this is the real-time process, how we are making the things, and I'm going to kick off this implementation start from tomorrow. I think it would take at least 2 to 3 days of time to complete this whole execution, guys, whatever I talked about today, a step-by-step process. Tell me one thing, guys. Of course, there's a lot of effort here to make the things happen, doing the implementation. But let's say you spend 2 3 days of time and you prepare everything, whatever I have discussed today. After that, do I need a DevOps engineer to do the build and deployment? No, right? Once you spend some 2 days of time and you prepare all the pipelines, everything, later on, whenever there is a source code changes, the Jenkins will take care of automatically to take the code, right? Do the build, do the deployment, everything will happen for you. You don't need to right? Spend time again and again each time when there's a source code changes. So though you are spending efforts in preparing this whole pipeline automation, still it is paid off, right? Because later on it take care of automatically for you. So for now, I don't want to make it more complicated by adding more tools, like as I see question in the chat window, right? The ECR. So for now, let it be a minimal complexity by using the Docker. Once this flow is executed, then I'll definitely talk about the ECR integration as well. It's just easy process, changing the repository name.